Hey, welcome back to the Register's front parlour, where we're looking at the results of our server management workshops that we've been having. Today we're talking about power management, what you've been telling us, and also what the experts have got to say about what you've been telling us. So, who are these experts? Today, from Intel, Ian, you're very welcome.
Thank you, Tim.
You've been in here before, but only when we had the big table.
It's nice with the table.
Tell me, being from Intel, can you do the bongs? You know the ones.
Bing, 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 bing.
Thank you very much. That's all we need to know. And also from Freeform Dynamics. Now, John Collins's colleagues have been getting a little bit jealous. He's been getting too much screen time, so they've locked him in a small cupboard under the stairs. And today we have Andy.
Good to meet you, Tim.
You're very welcome here as well. Now, last week we were looking at a little bit of analog PowerPoint, because I know that some of you get disturbed when there's a webinar and there aren't 50 slides. So I did some of that. I had a request for a little bit more, so I came up with a couple for you today while we get going. As you can see, the relative value of a bird depends very much on its location. And for those of you who like diagrams, there's John Collins. He's locked under the stairs. So, yeah. We hope that explains everything you need to know. Power management. Why are we discussing power management, Andy?
Because we're sadomasochists. But on the whole, it's really because I think business is moving on. What we're finding is that the cost of electricity is going up and its supply is limited. And also we're finding the business wants us to be more effective and efficient in this time of change. We're having one of the biggest recessions of the last century. It's putting pressure on operations, on efficiency, and on the need to make money. And all aspects of the business need to look at ways to be more efficient. And one of these is to look at the management of power in the data center and also across the whole business and look at ways to be efficient.
But I'll tell you what, Ian, there's been a lot of hype around this, hasn't there?
Well, there's a lot of stuff in the press. Everybody wants to be green, everybody wants to be more eco-friendly. And obviously there's legislation coming in as well. We were talking earlier about the CRC.
That's the carbon reduction commitment.
Absolutely.
Big businesses have to pay for their carbon, effectively.
Indeed. And obviously, you know, people are looking at, you know, how can we reduce costs? How can we reduce our carbon footprint? And when you look at, for example, if you looked at the data center and you looked at the overall costs in the data center, you probably, you know, in our estimation anyway, about 74% of the costs are down to, you know, the power consumption and the servers in there, right? So that's, I guess, why we're talking today about it.
Well, there is the other thing you were mentioning to me before, Ian, that there is no power left in some places. That's
right. So if you look at an example would be Canary Wharf, you can't get any more power in, so you've got that fixed amount of power to use. You know, how do you become more efficient in using it on a day-to-day?
Okay, now, Andy, there's another problem with this that one of the respondents pointed out, which is that the power tends to come out of a different budget than the server budget.
That's absolutely right, and is one of the big challenges that IT as a whole has to face in this new environment. And I think things like regulation may start to change some of the mindset behind that. But the reality is power is nothing without control. And the IT department especially needs some of that control to actually drive some of these changes through. Part of that will actually be getting the voice and the ear within the business and getting political buy-in either from the board or from, say, the facilities management or whoever controls the power budget. Things like the carbon reduction commitment, for example, expects all aspects of the business to reduce their power usage and become more efficient. And this is one way to start pushing change through.
But it's one thing to be expected to do that. There's not a hell of a lot of an incentive, though, is there?
No, there isn't if you take that viewpoint. But the other is, what benefit can you actually take out of this by if you turn it round and look at the efficiencies you may be able to drive, take back to the business and communicate. You may even be able to go in with a boast saying, look how much more efficient we've become. We've actually taken cost out, made the business more efficient, and we've done more with less.
Do you think in the future, Ian, that there will be more direct responsibility for the power usage into the IT department?
Well, I think there probably has to be, right? Yeah. Because, you know, as I said, servers are going to be one of the largest users of that power. Obviously, you've got the cooling as well. But, you know, my take on it would be, if you can go back to the business and say, as a result of some of the efficiency gains, whether that's through consolidation, maybe we'll talk on more on this stuff.
Yeah.
You know, I can save you X million or $1 billion, right? Okay, maybe $1 billion's too big a number, but
yeah, I was going to say you've been dealing with some very big customers, haven't you?
But certainly in the order of, you know, millions of dollars of savings, right? That becomes attractive, right? If you're the CFO and you can say, I can save you $2 million on your power budget, right? Or whilst, you know, keeping to the SLAs that we've agreed in terms of running the IT business, they bite your arm off.
Okay, well, let's have a look at how we do that then. And one of the problems here seems to be knowing what you are actually spending today on power. Is that the case, Andy?
Absolutely. So in the vast majority of cases, the data center is almost blind in terms of where power goes, where it's consumed, and how efficient it actually is. So one of the issues is, how do you start to tackle the low-hanging fruit? Can you even identify it? So the first thing may be to actually perform an audit, go through a management cycle, just catalogue what you've got, maybe what its maximum power draw is, just to get an idea, and then look at areas.
That's very rule of thumb, isn't it?
Some of this may be, but what you're trying to do is not overload with bureaucracy and cost. Do you really want to go out and spend a lot of money trying to cut power when you may be spending more than you may potentially save? So the first point of thumb is to actually have an audit of what's there, understand what's in the data center, and maybe then you'll get an idea of what the biggest consumers may be and start to monitor those first. Tackle some of the big, most obvious issues first, even before moving to technological solutions.
So what is going to be the big, most obvious things that people are going to find?
We'd be looking to things like the large storage systems, for example. How can you optimize your storage around it? Your large servers, can you consolidate your workloads down from many servers to fewer, is one of the first approaches. You don't even need a power meter to know if you take a number of servers out of commission, you're starting to save
You're going to
power.
be using less power, yeah.
Absolutely. And then it becomes something like a management cost. But often these things dovetail with each other. So you'll have a management or consolidation and virtualization program going on, and you can get power efficiencies out of that. The trick then is to actually start to communicate those efficiencies and say we are reducing power as a result of these projects that we're putting in place.
Okay, and I know a lot of people in the server business, usually at about this point in the conversation, say, well, this is a good argument in favour of buying some new servers.
Oh, Tim, you set me up nicely there. Yeah, so you're absolutely right. And, you know, you can articulate that in a number of ways. You can look at the advantage that we get through Moore's law, right? So continuously shrinking of the transistors and the CPU saves power, gives you more performance. But quite frankly, you know, if I go back to 2005, I can replace 20 of those servers with one server today. So, you know, I've just consolidated, you know, 20 servers down, saving you a bunch of space, a bunch of power, and giving you more space in order to do the other things that IT needs. You know, there's absolutely, you know, technologies in the server silicon today, you know, that where we can shut off the cores, you know, so that we can use, we can shut off the memory, we can save power that way. You know, it's become a lot more intelligent, right? If there's a peak in your workload, we can adapt to it. We can use something called turbo boost. If the workload isn't there, we can essentially go to sleep and save energy that way. So that's almost at a silicon level, but there's also platform technologies as well.
But here's the thing, having given you your chance on that one, the trouble is, most people who are, like I say, we can't just afford to go out and buy a bunch of new servers. And if they're being mandated to save money on power, it's very unlikely that they save money on power and spend it all on new servers. So is there very much that they can do with what they've got if it's pre these technologies?
Yeah, so if you're not going to go and buy some new servers, there's absolutely stuff that you can do, and some of it's not even obvious, right? So some of it's about, for example, taking your software and tuning and optimizing the software. You know, are you running it on the latest compiler? Let me give you an example. We were working with one of the ISVs in the city, and you know, it was taking many hours to do a credit finance calculation. By tuning and optimizing it, okay, yeah, we are running it on the latest hardware, but you're going to get some advantages anyway. You can actually reduce that from many hours to minutes. Now, that obviously has a knock-on effect on your power consumption.
So that's just simply by recompiling what you've got already? You're going to use less power.
And looking at the algorithms and tuning and optimizing. Let me give you another example. Again, it is in the latest hardware, but we added some new instructions to do with security. It's called AES&I. Thank you. We can have a little PowerPoint on that later. And essentially what it does is it does SSL in hardware, right? So it does that security stuff in hardware. So again, we're seeing speeds up on some of the codes of 50%.
Andy, this sounds a bit unlikely to me. Is it true?
It can be true. Again,
it can be true.
You have to have the hardware support, and you've got to get all of your developer systems and your compiler guys and your test cases in place to do so. So Intel, for example, is putting in place the foundations now. This is a time to build and to start putting in place is the whole foundations to have the solution in place as we move forward.
And this is going to be more directly relevant to a certain kind of user.
It will. Maybe, for example, if you're a high-performance computing house, you may have more direct control and you can bring costs down immediately. Whereas if you buy a lot from ISVs, so the Microsofts or the Oracles, others of the world, or the more off-the-shelf business software, you may have to put pressure on them through product upgrades and other issues. And again, it fits to what is your company's approach to power management overall. Do you have a message that the company likes to portray around sustainability or green or other messages? And if you're that type of company, you can put pressure on your supply chain to help you meet those goals. And on the other side, it's about just communicating and interacting with the community of providers that you buy from.
There's very few companies that this is going to be able to lead their server refresh project, isn't it? It's going to be an aspect of what they do, but it's not going to be the be-all and end-all.
That is very true, but it should be one of the central tenets of the buying strategy. It should be, how can we monitor, manage and optimize the power consumption through both the software we run on the device and through the actual attributes. So does the server support power down? Do you have an efficient power supply? So can we run it at 80% utilization rather than 5% and save a lot of those idle power costs?
Ian, for one of the problems that we've got is for the sort of server estate people have already, there are few tools to directly say how energy efficient it is.
Yeah, you're absolutely right, and I think this is something that Intel has been investigating as part of our R&D, and we're working on some developer kits that are they're actually out there today, and I can give you some case studies. We did one at BMW, did one at Oracle actually, where they were looking at what the SDKs enable you to do, just so people understand, is they enabled you to monitor real-time the power usage at a server level and also at a rack level, right? So what you can then do is you can say, okay, this server, I want to downgrade a bit, right? Maybe it's not high performance. Maybe I can save some power costs, and I know I'm going to, the calculations or the end result is going to take a little bit longer, right? But overall, I can manage the hotspots in my data center as a result. Another way of doing this is, you go into a lot of data centers and you'll see racks that aren't even fully populated. If you can curtail some of the power, what you can do is then you can actually start filling those racks, right? So you don't then have to build a new data center.
Right, because sometimes those racks are not fully populated because of the cooling problem.
Exactly, yeah.
Does this all require new hardware?
Not all of it requires new hardware, and I'll give you an example. One of the things that Intel IT has looked at, and it's a proof of concept, and it is looking at air exchangers. And this is, so the usual example is you go into a data center, what happens is we take the hot air, we run it through a chiller, and it becomes cool air, and we pump that round, etc. That's actually, quite costly. What we were looking at doing is, and this wasn't small, right? This is a 1,000 square foot facility, 900 high performance servers, and what we're doing is we partitioned it into two, right? So 2 lots of 500 square foot. One is chilled, and one is using an air exchanger. So we take the cold air from the outside in, right?
Just sucking it from outside the building?
We just take it from outside the building, and we replace it with the warm air inside the building. Now it's in a desert environment, okay, and we filter the air.
Isn't the air outside hot?
Yeah, it is. Yeah, it's up to. So we really pushed the limits of this, right?
Yeah.
So, we're talking air up to 32 degrees centigrade. and down to about 18 degrees centigrade. So we take the outside air in, we push the overall limits of the data center slightly higher than you would normally expect. But what we found is, overall, we had a 67% saving in our energy costs. Now, if you translate that and you say, okay, well, that was a relatively small data center. If I take that to a 10 megawatt data center, what does that translate into? That translates into savings of $2 million, right? In fact, 2.6 or something.
Okay, so these sorts of things are interesting innovations, Andy. I guess what a lot of people are doing is they're struggling with the design of a data center that's been around for 4 or 5 years now, and it's not very energy efficient in the sort of efficiency we're talking about now.
Absolutely, and these things do take time to change. The point is to recognise the need to change and to try and bring those types of architectures and solutions into place now, so that in a few years you're in an optimal situation.
Do you think it's a good idea to start tinkering with your data center, or I mean, the problem that you've got is you'll never get anything that's energy as efficient as starting from scratch again?
That is true, but how many of us have a chance to turn such a new forest, not just necessarily a new leaf? So the point is, I think, is to try a lot of the best practice where it's practical and to be pragmatic about it. So the point of trying to run the data center at a slightly higher temperature, that can alleviate a lot of the pressure on your cooling system. And given that today cooling is often half of the power budget in many cases, that can be a significant saving, as well as possibly stopping you having to upgrade or maintain those types of facilities as often. So that's one small way you can start to move towards it. When you have advanced monitoring features, you could actually monitor the workload and the heat within each individual server to proactively move workloads around the data center. So you can actually reduce your cooling needs by concentrating workloads where it's not a hotspot.
Ah, I see. Now, we've got this far without mentioning virtualization yet, but I suppose there you are, I've done it. So what effect does this have, Ian, directly?
So virtualization gives you the ability to move, VMs around the data center. What it really gives you, though, is the reassurance, I guess, at a platform level. So it's like putting all your eggs in one basket, right? So you're just taking your 20 servers, that I spoke about, and you put them onto one server. So you've got 20 workloads. You want the infrastructure to be, safe, reliable, and you want to have those additional features on, because you're also looking at things like network I/O and bandwidth in and out of the server, right? So again, we could go on and on in terms of the power consumption here. If I relate that, let me give you an example. So again, if you upgraded to your network, right, to 10 gig E, right, you can get rid of a whole bunch of cables and all of this kind of stuff. So again, you can reduce your power consumption that way. But virtualization is important because essentially you can move your workloads around. So it goes back to Andy's point around, look, if you can actually work out this server has a hotspot here, and we've got a cooler part of the data center, and we can move that workload over, then that's where virtualization comes in.
Andy, the people who are doing virtualization, have they got the expertise to be able to look at it in these ways? Yeah.
Well, we've got to recognise that virtualization is still in its very early days, and it has started to move out of really a lab environment to a production environment. A lot of people are using it really just for consolidation today, and as we've already discussed, that can give you immediate power savings if you reduce your hardware usage. But as you start to then get the intelligent data center that's instrumented and monitored, this will come with time. But today the skills aren't there. But as with all technology, it takes time to build and to come to market.
How much time?
Generally, you're looking at cycles of 12, 24 months to get familiar with the skills and reach sufficient maturity. But we've already got technologies today demonstrating this is possible. We can see things like vMotion and the ability to take a workload almost seamlessly from one server, move it onto a virtual host on another server that's in a cool part of the data center, or maybe even on a higher performing server if you need that instantaneous performance boost. So you can cut your overall power consumption by only moving workloads to the most powerful servers when they need it and when there may be a penalty to pay.
Yeah, and the guys that are producing they're producing virtualization management software at the moment, they're making good progress with this, yeah?
They're starting to. We're seeing leaps and bounds.
Right, it's on the starting to
Absolutely.
Yeah, right.
And I think we've got to realise as well, this is a multi-vendor, multi-application environment. There won't be one perfect solution. So what is good for one company may not be good for another. So it's about taking your own circumstances and applying best practice and the best of technologies that are available to the particular problem that you have.
Ian, do you think that the guys that are producing the sort of management software that we're going to need to make this work, are they keeping up with what you're doing? Do you have to shake them and say, get on with it, guys?
No, I think it's an industry thing.
Yeah.
Right? It's an industry problem, and it's something that it's not just Intel. It's not just a hardware. It's a software. Everybody owns it in the IT industry. And it's something that through industry initiatives like the Green Grid or the Climate Savers, Intel is in there driving. And so, yes, we own a part of that. We own making some of the building blocks available to people so that they can incorporate, the ability to look at the real-time power consumption as part of their, management ISV software.
Historically, when things have relied on the whole of the industry working together, it's taken a very long time to do it. Is there any cause to be more optimistic this time?
Yeah, probably the cost of electricity going up. I don't know what your power bill's like at home, but mine's certainly skyrocketing. So it is seen as, and also I think everybody's on the green agenda, right? So I generally think there's a good industry initiative behind it. People want to do it. People want to reduce the carbon footprint that IT is putting out there.
Yeah, I'm regretting putting that data centre in my spare room now, I have to say. Storage, that's another problem, isn't it, Ian? That's a big drain on power.
Well, so our estimates actually show that servers are probably more of a drain on power than storage. Andy may disagree with me.
It's no drain on power at all.
But storage is up there as well. I mean, you can add in storage, you can add in networking. One of the things that people can do actually, and this is becoming more prevalent, is using SSDs, right? So you can use an SSD, and we're actually
SSDs, solid
state drives.
Yep.
In servers, and you can actually, not only are they more performant, quicker, etc., but they're actually you get a reduction in power consumption as well. We're seeing up to 74% in some cases.
That's quite significant. Are we seeing this in the real world, Andy?
Yes, we are, but you have to put them in the right place at the right time.
What is the right place?
So a lot of data is transactional and in heavy use, and in that type of situation, SSDs can really help, and they also boost performance at the same time. But what we also have to deal with is that large persistent pool of data that we don't ever seem to get around to managing. And what do we do? Do we keep those disks spinning so everyone has constant access, or how do we actually take them offline and make that whole legacy data pool more energy efficient as well?
Well, that's a good point to sort of move on to some of the broader things that can be done, because I guess if you look at this project tactically, you can make savings here and savings there. But if you look at it in the slightly longer term, it might end up doing things in different ways. And I guess one of the first things we have to talk about is the problem that often gets reported to us, as you hear, is the problem sprawl, server sprawl especially at the moment. Andy, that's going to have an impact on power usage, isn't it?
Absolutely. And if we consider just being able to take and even decommission some old servers and make better use of them, the ideal way to start, for example, is virtualization. And again, just basically putting in place application performance monitoring to make sure that you're still providing the required level of service while taking the old kit out. Then, of course, we can invest in new stuff that's instrumented and more power efficient to do so. And on the other side as well, we can also look at doing IT differently, not just data center, but can we use data center type technologies to reduce cost elsewhere throughout the business in IT? So can we do a virtual desktop infrastructure that's hosted on servers and replace a lot of power-hungry desktop machines with low-power thin clients, for example? But that moves some of the cost and the budget out, say, of the desktop environment into the data center.
Oh, so now somebody else gets involved.
So someone else gets the blame. Yes.
Yeah. I mean, we started looking at sort of quick and dirty things here, Ian, but now all of a sudden, we're into really big projects. Is there a sufficient saving here to justify looking at this in a sort of like an 18-month, 2-year time frame?
Yeah, absolutely. If you look at server refresh, right, and this is something that Intel for our own IT group has been looking at, we estimate savings, they're significant, right? So they're $200 million savings.
$200 million out of?
In 8 years, right? So $200 million. And, this is mainly down to, having a server refresh, right? So every 4 years, let's get rid of the old servers, right? They become out of warranty. You get risk associated with the business. Let's give them to some schools or something, or other people who can make use of them. There are incentives out there for reducing power, right? So the Oregon Energy Trust actually gave us a rebate because we use less power in our data centres. Well, okay, that's worth $250,000 to us.
You don't need a rebate. You've got enough money already.
Tim, we can always have a rebate, right? We're the largest user of wind power in the US. So, again, it's talking, about, maybe you move your data centres and you park them next to a wind turbine, right? So you don't have all the grid stuff in between. They're optimisations that people will be looking for. But seriously, server consolidation, we are looking at saving huge amounts of money by doing that, by doing virtualisation, by reducing the number of servers that we maintain.
Yeah, Andy, these large-scale projects, it's very difficult to cost justify them on power saving alone. It's difficult to work out how you make a spreadsheet around this, isn't it?
It is, but that's a fundamental part of large-scale IT implementations anyway. What it can do is it can help to justify some of the cost savings and return on investment. And again, it's raising the level of awareness across the business that IT can also reduce its own carbon footprint, but also help the business itself reduce carbon footprint. And that ties again in all these legislation, such as the CRC, etc.
Well, a lot of the legislation at the moment is poorly defined, isn't it? It's very difficult to make predictions of cost savings based on it.
That's very true. It is a woolly area today, and some of it is brand new legislation, and we have to take time to get to grips with it and to learn what, in reality, how it will work and how we will report the improvements in usage over time.
Ian, as we're sort of drawing to the end now, we haven't got much time left. Could you pull out just a couple of things that people can do, like today, this week, this month, that's really going to help? Where do people start on this?
People start by, I'll
put you on the spot. Andy, I'm asking you this one in a minute as well, so prepare an answer.
Andy and I will agree that you will look for the low-hanging fruit, and I'm sure everybody's going...
Come on, what's the low-hanging fruit?
So the low-hanging fruit is, look at your old servers, right? If you've got single-core, dual-core, absolutely, you can make a real business case for getting a payback on those servers in as little as 4 months, right? So there's a business case you can take. You can chuck those out. You can replace them with more modern, energy-efficient servers. That would be probably the number one thing I would do. I would then look at virtualization, taking some of the workloads, virtualizing them, and then I would be looking at doing some benchmarking activity to say, what is our power consumption? What are the hotspots? Where do we need to go? Where does the business need to go? And where can we reduce our power consumption?
This sort of rule of thumb stuff that Andy was talking about, just having a look and seeing how much power it might be.
If I went into most data centers today and said, okay, what's your PUE ratio, right? Power usage efficiency ratio, I'm not sure anybody would be able to give me an answer.
Or the people who wouldn't give you an answer would be up at about 2.5 or something like that.
L2 or something.
Yeah, something like that.
You start looking at the PUE and you go, okay, if I can save 10%, actually that has got a big monetary value, right? So, that could be half a million dollars saving there.
Okay, Andy, for you?
For me, it's about trying to get control of, say, the power budget. And if you're starting to reduce your energy usage, can you translate that back from either the CFO or maybe facilities management into cash for your IT budget to invest in other areas?
So you're saying people should actually go and say, give me control of a budget here, and I will save you money?
Or go out, get to know the guys, get to interact with them, and share the pain, and try and share also the reward. If you manage to reduce the energy cost, get at least a percentage of that back to reinvest in IT.
Right, so a part of this is political, being able to go and brag and tell people what you've done.
Absolutely.
get the kudos for it.
Absolutely, because without it, there's going to be very little more money coming into the budget, no matter what you manage to do. So communicating and actually being able to demonstrate, so coming back to management and concrete examples of where you've managed to cut power and demonstrably so.
All right, thank you very much, guys. We are out of time on that, so there we go. So to sum up, it's Ian says there's a lot of hard work there, and Andy's recommending you go to the pub with the people from the other department. We hope that's been helpful. We hope we covered some of the comments that you gave us on this. As always, let us know what you think of what we're doing, because we like to do more of what you like. So from Andy and Ian, and from me, thank you very much. Goodbye.
Thank you.
Thank you.